As I mentioned in the week checklist, the Connect homework for this week was just kind of abysmal in terms of certain objectives. They just didn't have it as an option. And so I directed you to some questions in the book, including 12.81, which is found on page 445 and has A, B, C, and D. So I'm going to just kind of read the problem and then walk you through A. Ethers may be prepared by the removal of water, so it's a condensation reaction between two alcohols, as shown, blah, blah, blah. Give the structures of the ethers formed by the reaction of the following alcohol under acidic conditions with heat. Provide the IUPAC and common names of each reactant and product. So we're going to look at A together, which is, this is what it shows next to A. It has 2 CH3 CH2OH. So that's, we're going to do what they're asking for this problem. So I'm going to start with by actually doing a little bit of naming, because that kind of helps me. So I have 2 of these 2 carbon groups. So a 2 carbon group would be F, and then it has a hydroxyl group on it. So this, the IUPAC name of this would be ethanol. And we'll come back to the common name in a bit. But okay, so let's start with the first part. Give the structure of the ethers formed by the reaction. So let's do that down here. So I'm going to take this CH3 CH2 OH, and I know that they have a 2 here, but instead of doing that, I'm actually going to go ahead and put in another one. And oh, there's something I like to do when I know I'm making an ether. Let me show you. When I know I'm making an ether, I like to draw the second one backwards. So I've just taken this and drawn it the other way around. It's really the same thing, and saying 2 is the exact same way. Well, if I take these 2 molecules of ethanol and I react them in slightly acidic conditions with some heat, I'm going to get an ether, as the problem kind of tells you. So what's the structure of an ether? Remember, it's the ether or the ether bunny. You either get it or you don't. There's our ether. So how is that going to happen here? What's the very generic mechanism? So as it said, the removal of water. So I'm going to remove a water molecule from these. So one of these is going to lose its OH. So I'm going to cross it out, or tell myself, okay, it's leaving, this OH is leaving, and that's part of the water. Remember, there's our chemical formula for water, or our structural formula. So half of it comes from one of the alcohols, sorry. Then this other ether is going to lose its hydrogen. That's also going to leave, and that's right here. That's what makes the water molecule. So I've accounted for the water, and we call this a condensation reaction because we condense these 2 molecules into one larger structure. So we condense them together. So if you condensed a book, you might shorten it a little. So we shorten it a little and we hook them up into one, and we do it through the removal of a water molecule. So then how do I take what's left? So let's identify what's left. So I have this that's left. And if you think about, oh, that's a bad color for that. If you think about what it looks like in a larger kind of structural formula, you can see I have a carbon that does not have its question mark. It's bonded to nothing because this hydroxyl group has left. And then over here, what do I have left? I have this, including this oxygen. So if I expand that out, let's see what I have. Here's my CH3 group. There's my CH group. And it's bonded to an oxygen. So you can see this carbon actually does have a full valence shell. It's bonded to 4 things. But my oxygen is not. It's lost the hydrogen. So it's gone. So what does it bond to? Well, it's a perfect situation. These 2 can bond together. So this oxygen could directly, through a single bond to this carbon. So let's take this structure and work on putting it over here. Oh, I was using red for the, there we go. So plus, and then I can leave it expanded if I want, or I can kind of recondense it. CH3, CH2, O, and I didn't have to do that, but I just kind of like to personally. There's my O single bonded to CH2, CH3. You can see then I have the general formula of an ether. So let's talk then, so that's how we can condense, we can take these two ethers. One's going to lose a hydroxyl group, the other is going to lose a hydrogen, and then they're going to bond together, the oxygen of one to the carbon group, the alkyl group of the other. So let's talk names, since it asked us to do some naming, and we talked a little bit already, so I have to decide my color, you guys. This is very important. So we'll start with common name. So the common name of our reactant would be ethyl alcohol, where we have the word alcohol in it, and we just name the alkyl group that's attached to it. So common name ethyl alcohol, and as we already identified, the IUPAC name would be ethanol. And we don't need to locate that because there really is only one option for the hydroxyl group. If it's on this one, it's still carbon 1. If it's on this one, it's carbon 1. So what about for our ether? So I actually really like the common names for ethers, at least for the smaller, simpler ones. If you get bigger ones, then I think the common name gets pretty goofy too. The common name would be, so we have what? An ethyl group here and an ethyl group here. So the common name of our ether would be ethyl ether. So I like this because when it has this name, it tells me what it is right there in the name. And then it's just saying what's on either side. And if they were different things, if this was a methyl group, and then it would be like, you know, ethyl methyl ether or something like that. But since it's two of the same, diethyl ether. Now the IUPAC name for this one is a little bit weirder. So they're identical on the two sides. So normally we go which one has the longest carbon chain, but they're the same. So we're going to say this is the parent chain, and it's eth, so we would name it ethane, right? So that's going to be, the parent name is just ethane because it's saturated 2 carbon, no double bonds, no triple bonds, just ethane. Now this portion, what I have left, is going to be named as a alkoxy group. Alkoxy. And so what that means is this alkyl, that comes from alkyl. So it's a 2 carbon group, so that would be eth. But rather than ethyl, I replace it with this oxy. So if this was ethyl, but I'm going to get rid of it and place it with oxy. So the IUPAC name of this product is ethoxyethane. And I don't need to locate it because it's the only option. If this oxygen was single bonded to this one instead, it would still be a 2 carbon. It's the same. If you have a larger one, it can matter because the oxygen could be bound to carbon 2 or carbon 3. But with this, in this case, just like with ethanol, there was only one option. It's the same. So there's our common names, and there's our IUPAC names. So the gist of this problem comes down to the fact that you can condense an alcohol into an ether. And that happens by one of the alcohols losing a hydroxyl group, and it doesn't really matter which. One of the alcohols losing a hydroxyl group and the other losing its hydrogen off its hydroxyl group, and the two bonding together in that place that's missing and it is now open. So I hope that helps.